scope, and lifetime. So lifetime is going to be new if you haven't programmed in C before. All right, so the C language looks a lot like the Java. Well, sorry, the Java language looks a lot like the C language. So when you're using a variable in either language, the variable must have a type. And so just like in Java, when you write something like int x, you're saying there's a variable called x, right? Its type is int. In C, the value of x is not initialized at this point. So if you use x without assigning it a value, it could have any value. So if you print out x, it might be 0, it might be something else. The confusing thing in C is that if you write these small little test programs, often, in this particular case, if you print out the value of x, it's going to be 0. But it's not until you actually try to do this in a more complicated scenario where suddenly an uninitialized variable is not necessarily 0. So for example, if you're accumulating a sum, and you assume that x is going to be initialized to 0, sometimes the sum will be computed correctly, and sometimes it won't. Right? And so in those cases where x happens not to be 0, when your function starts to run, you'll end up with the wrong sum. Right? So that's uninitialized. When you declare and initialize at the same time, C calls that initialization. And so that's exactly the same as in Java. Right? So that's initialization, which includes declaration, and that's just plain old declaration. And then finally, that line there, I don't know what, something's going on with Jupyter. It's dropping some of the semicolons. They're actually there. So in the markdown source, the semicolons are there. Whenever Jupyter is rendering them, though, it's not showing them properly. So there are semicolons here and here. This line here is, so when you write z equals 100, where it's not a declaration, that's called assignment. Right? So there's actually 3 separate things going on here. Right? There's declaration, initialization, which includes declaration, and then assignment. These are all technically different operations in both the C and Java languages. And so in particular here, where there's an assignment, in C, all variables can be initialized. So you can declare its type, give it a name, and set its value, all in one statement. But not all variables are assignable, which might surprise you. So here, we can assign the value 100 to z. But we'll see later in the course, there are some types of variables that you cannot assign a value to. You can initialize them, but you can't assign them. All right, so of course, C has the integer types. They're more or less the same as Java, except you also have unsigned versions of all of your types. Boolean values are also different. So in Java, Boolean values are their own thing, right? True and false. In C, Boolean values are, historically, they're represented as an int. In modern versions of C, they have their own type. So you can use the word little b bool, as long as you include that header file. And then you can use the constants true and false. But internally, they're still being stored as 1s and 0s. So we'll look at bool in just a second. There are all your integer types. So you got more of them compared to Java, and they come in 2 different variations. They come in a signed and unsigned variation. Right? So where is it? So we have a signed car, and we have unsigned car. Car is unusual. There's also a plain old car. And believe it or not, these are all different. Int, you've got int, which is the same as signed int, and you have unsigned int. You've got long int, which is the same as long, which is a signed long value. And you also have its unsigned variant. So the unsigned variants are never negative. Right? So their minimum value is 0, their maximum value is some maximum value. Now in Java, all of your primitive types, they have a predefined size in memory. Right? So Java says an int shall be 32 bits. Right? C doesn't say that. So you have to remember that C is one of the early programming languages. One of the early modern programming languages. Back in the day, there were many more CPU manufacturers than there are today. So today, everybody has more or less agreed to do things in a certain way. Right? And there's only 3 significant CPU manufacturers around for desktop. But in the early days of computing, there were many, and no one knew, or people had not agreed to do things in a certain way. So you had one manufacturer manufacture a CPU that uses 8 bits as its word size. So the word size is just the number of bits of information that the CPU wants to move around. So some manufacturer might have had an 8-bit CPU, someone else might have a 10-bit CPU, someone else might have had a 12-bit CPU, right? And there's all these weird things, right? So no one's CPU, people's CPUs were not consistent with one another. And so if you want a language that can run on every CPU, you could not fix the size of these data types. And so C mandates a minimum size for all your data types, but it doesn't say what the actual size should be. Right? And so you can see bool is at least 8 bits, right? Even though you could store a Boolean value in 1 bit, right? True or false, on or off. Right? It has to be at least 8 bits in C. Char is always 8 bits or more in C. Right? Ints are 16 and long ints are 32. Right? And these long are 64. Right? So the actual size in memory of the types is not fixed in C. Right? There's only a minimum size. The ordering is fixed, right? And so the table is showing you the order from smallest to largest. If you want to know what so sizes in C are measured in terms of units of the size of char, right? So the language says char shall have a size of 1, right? It's actually 8 bits, but the language says the size of char is 1. And everything else is measured in terms of multiples of char, integer multiples of char. Right? So your int might be 2 or 4 or 8. Right? Long int might be 2, 4, 8, or 12 or 16 or something like that, and so on and so on and so forth. If you want to know the size of something, that's what the size of operator is for. Looks like a function, it's actually an operator. So size of, and then a type, tells you how big that type is, how much memory it occupies, in terms of multiples of char. Right? Where char is always defined to be 1. So that's how you call it right there. Right? Size of and then the type. You can also use size of and a variable name, and it'll tell you the size that the variable, the size that the type of the variable occupies. So I'm just going to use printf to print out the name of the type, right, with some spaces, then a colon. I'm going to print out the size, so we haven't seen this conversion yet. So this conversion here is %LD. So %D converts as an integer value. There can be a modifier in front of the D that tells printf how big this thing is. So LD is for a long int. And if we go back to here. So this is the documentation for printf. It's not just printf, it's a whole family of functions that all work more or less the same way. If you scroll down, there's a table, and it tells you over here, up at the top, what your modifiers can be. Right? And so L is right here, and when you apply that to I or D, that's a long int. I really should be using Z here, over here, which is for the type size T. Right? And I'll explain what that is in just a second. And so size of actually returns a value whose type is called size T. There we go. And explained down here. It's explained right here. And so size T is the type that can hold the maximum size of an object that is allowed in C. Right? And so if you use it as an index, it is the largest, it can hold the largest possible index that you can use to address an array. Right? And so that's what this type size T is. It's unsigned, right? So between 0 and some maximum value. Depending on your computer and your operating system, the maximum size of size T can differ. Right? So all of these things, none of them are fixed. So here I'm going to print out the size of a card, then a bool, and so on and so on and so forth, right? And we'll see what we get. Okay, so the size of car is 1, so the language says the size of car shall be 1. That's how it's defined. Right? The size of bool is also 1. Short is 2, and int is 4. So on my computer, it's probably 32 bits. Long int is 8, so on my computer, it's probably 64 bits. Right? And then you got float and double, and then these things here, if you don't know what they are, these are pointers. And then we'll learn about these later in the course. These both have size 8. Right? All right, so bool is your Boolean type in C. You don't have to use bool. You can just use plain old int if you like. So the way it works in C is that any value that's 0 is considered to be false. Any non-zero value is considered to be true, right? 0 false, non-zero true. So bool, right there, right? Or underscore big B bool, they both represent the same thing. So when the C language introduces new features, so when it introduces a new type, it gives it a funny name. Right? So here, the funny name, it starts with an underscore, and then it's capital B bool. You can write that if you want to. So you can just use that if you want to use Boolean type. It's a little bit easier to read that. But if you want to use the name little b bool, you have to include that header file there. This type here can store true and false values. So just like in Java, the constants are true and false. But under the hood, it's just an integer. So the value is either 0 or 1 in this case. So if you put in a value that is numerically 0, the value 0 gets stored. If you put in the value false, the value 0 gets stored. If you use any non-zero numeric value, including a floating point value, you can store it in a bool. It just gets converted to 1. So here we've got our flag is true, right? And then a little if statement, right? It prints true if flag is true. It prints false if flag is false, right? So this is going to print true. If you put in a 1, that's fine too, right? Still prints true, right? And the really weird thing is that you can put in like a -1, and that also works, right? It's not 0, so it becomes true, right? And you can even use a signed value, a floating point value here, and the compiler is perfectly happy converting that over to a Boolean value. Right? So that's a bit odd. Anything at 0 gets converted to false. And I believe that's true for -0 as well. Yes. So strange, but that's the way it works in C. Historically, logical values were just zeros. Were just the ints, so they'd use 0 and 1. So because historically we use 0s and 1s for true and false in C, there's no specific conversion for the Boolean values. So if you want to print out a Boolean value, you're always going to get 0 and 1, and you're always going to print it as an integer. So for example here, my flag is false, right? %u is the unsigned int conversion. You can use I or D here as well. It's going to work just fine, right? I'm going to print out the value of the Boolean flag. So it's false, so I get 0. If I make it true, you're going to get 1, right? And that's a little inconvenient if you're using the output to actually try to understand something about your program, right? Seeing 0s and 1s might be nicer if you saw true and false, right? Like you would in Java or Python. If you want to do that, you got to do all the work yourself. So here, I have a Boolean value again, right? I know that if I try to print this out, I'm either going to get 0 or 1. If I want true or false, I've got to do the work to make it true or false myself. And so the way that I'm doing it here is I'm printing out the flag as a string, right? So %s. Right? And now I have to compute the string for true and the string for false, given the value of flag. Right? So you could write an if statement and introduce another variable. That's awkward if you just want to print something out. And so here I'm using the question mark operator here. So the way you read this statement here is you look at the value of flag, right? Question mark means if it's true, right, the result of all of this gets replaced with this, right? Otherwise, that's what the colon means, right? All of this gets replaced with the value false, right? So flag is true, everything in this expression here gets replaced with true, right? And if flag is false, everything in the highlighted expression gets replaced with false, right? And so this expression here produces a value, right? It produces either that value or that value. It doesn't have to be strings. You can produce whatever values you want, right? You can produce 0s and 1s and floating point values, whatever you want. Right? And so this is the quick way to write an if-else statement in C that produces a value. Right. All right, the char type in C is similar to the char type in Java. It's used to represent character values. If you want to print a character value in C, you can use %C as the conversion. Right? So here I've got the char x. Right? If I want to print the x, I can write %C and then pass in the character like that. Right? And you get the x here. Right? If you use the chars are just integer values, though. So just like in Java, chars are ints, are integers under the hood. So if you print this out using the D conversion, you get out integer value corresponding to the char value. So here you get 120. Right? And so here you're getting the ASCII value of the x. Right? So ASCII happens to be the ASCII happens to be the encoding that's being used to map character values to numbers to character values. So if you print out a char using %D, you get the numeric value rather than the printable character. Right? Normally, you want to use %C here. Right? So just like in Java, there are special characters there are characters that need special treatment if you want to print them out. And so you have to escape them, just like you have to escape characters in Bash. Right? And so the escape character is the exact same as in Bash. It's the backward slash. Right? So the single quote, if you want that in a string, it's / single quote. Right? If you want the double quote, it's / double quote, and so on and so on and so on. Right? You don't have to memorize these things. %n, \n is useful to remember. Right? It's the new line character. All right, the integer types. So C has both signed and unsigned types, right? Unsigned are never negative. The upper end of an unsigned type is bigger than the upper end or greater than the upper end of the corresponding signed version, right? So if you have a signed int, then it can be negative. So its upper end is smaller than for an unsigned int, right? But that's just because the unsigned ints don't have any negative values. The C standard is funny in that it doesn't even say how the integer values are encoded in memory. So Java says all ints or integer types, they are all 2's complement. They're all 2's complement values. C doesn't even say they're 2's complement. It just says there's some sort of integer value, right? Your compiler has to figure it out. And it also says that the size of an int has to be at least 16 bits. So 2 times the size of char. If you want to print something out, just use %D or %I. If you want to print out a long int, you should put in the L in front of the I or D. If you don't put it in, the compiler will complain. It'll give you a warning. But normally, it'll still do the correct thing. Right? So if you go back to that table I showed you on the printf documentation, you can find the size modifier. Here are several of them illustrated. Oops, all right. Back here, run that. Okay, and so here we've got a char. Right? I've got a short or short int, the same thing. I have an int, I've got a long int or a long, and I've got a long int, which I think is the same as long. And then I'm going to print them out. So when you print out a character, if you want its numeric value, you can use %D or %I. Right? If you print out a short, you're supposed to include the size modifier in front. So that's H for short. Right? For plain old int, you don't need the length modifier. It's just %D or %I. For a long int, you should put in the L, and for a long, you should put in the double L in front. Right? Again, not worth memorizing. I'm just pointing it out. Right? And so when you print those out, you get the values that were entered in before. Right? If you leave them out, let's see if my compiler complains. It doesn't complain. Okay, so you may get a warning from the compiler saying that there should be an L here or something like that. Okay, C has enumerated types, just like Java has enumerated types, but the Java enumerated types are much more sophisticated than C's, right? So C's enumerated types, they're just integers. So they look like types, or they look like a named type, but they're not, they're integers. So here is an enumerated type called day, right? And so when you make your enumerated type, you tell the compiler what constants do you want to use in your enumeration. Right? So I would like my types to have the names Sunday, Monday through Saturday. Right? These get the values 0, 1, 2, up to 6 in this case. Right? Here's my enumerated type called compass. I would like the 4 compass directions. This says that the direction north is equal to 0, so 0 degrees. Right? The direction east is 90 degrees, the direction south is 180 degrees, and the direction west is 270 degrees. For month, I've got the months January through December. Notice that I marked January as having the value 1. C does the reasonable thing, and it makes February 2, March 3, April 4, and so on and so on and so forth. All right, so now that you've declared your type, you can go ahead and write something like enum day, and that now becomes your type. So enum day is my type, my variable is d, right? And I can pick a day, right? So I think I edited this example. So normally you would write something like Monday, and everything's fine, right? Here's my type enum compass, right? There's my variable dir, I want that to be south, right? And here's enum month, right? My variable is m, and I'd like the month October, right? These are just ints. So when you print them out, the only thing you can do is print them as ints. So here I'm using the %d conversion, and when you print them out, right, you get the day is 1, the direction is 180, the month is 10, right? There's no simple way to use printf to get out a month of October or a day of Monday, right? These are just ints under the hood. And in fact, you can store an int in the enum variable, right? So I can use the day 100, right? Which isn't even a valid day, but it works, right? So now you get a day of 100. And so this, the C's enums are really just a way to make your program easier to read. The compiler doesn't actually enforce anything about the enumerated values. They're integers, and that's it, right? So they're there purely as a device to make your code a little bit easier to read, right? Under the hood, they're just integers. Right? That's very different from Java's enum type. You have floating point types in C, so it's exactly the same as in Java, right? You've got float, you've got double. C also introduces long double, although on most computers, long double is the same as double. Float is guaranteed to be 32 bits. Double is guaranteed to be 64 bits. Sorry, is that guaranteed? Yes, they're supposed to be 60. On all modern computers, they're 32 and 64-bit floating point numbers. And they follow the IEEE 754 standard, just the way that Python and Java do. Long double may or may not be supported on your computer. If it's not, it just defaults to double. If you want to print a floating point number, it's %f. Right? So %f will print out the number the way you sort of expect it to. %e and will print it out in scientific notation. And %g will pick between %f or %e using some algorithm. Right? So use %f, you get out 3.141593. You always get 6 digits by default after the decimal place. %e is scientific notation. So it uses the e plus some integer. So the e means times 10 raised to that power. And then %g picks between %f, picks between a version of %f and a version of %e. Right? So here it's picked something that sort of looks like %f. Right? If the number gets very large, it'll resort to scientific notation. If it gets very small, so it has a very small, it's much smaller than 0. Much smaller than 1. Its magnitude is much smaller than 1. It will also resort to scientific notation. When you're printing out floating point numbers, often you will want to specify how many digits to print after the decimal point. And so that's called the precision in C. So the way you specify the precision is with a dot and then an integer value indicating the number of digits you would like to see. Right, so .1 means give me one digit after the decimal point. That means give me 10. And that means give me 100, even though internally there probably aren't 100 digits to give you. Right? On my particular computer, it does actually give you 100 digits. And it prints out a bunch of zeros for most of them. Right? So 1 digit of precision, 10 digits of precision, 100 digits of precision, unclear whether or not any of those, anything after somewhere around here is significant. In 64-bit, you only have, in 64-bit, you only have somewhere between 15 and 17 significant digits in a base 10 number. So everything else getting printed out here, probably not significant. So in C, you can have a variable that is declared to be const. So const means it's unassignable. So you can read, it's a read-only variable. If it's unassignable, that means that you have to initialize it. So you can declare and initialize, and that's it. You can't do anything else with it. You can look at its value, but you can't change it. If you try to change it, the compiler will flag that as an error. So it's sort of like final in Java. But remember, in Java, final means you can only assign to it once. Right? It doesn't matter where you assign to it, you can only do it once. Const means you can never assign to it, you have to initialize it. So there's a subtle difference there. In both cases, they're basically used to represent constant values. Right? So for something like pi, you might write something like that. Right? And it's normal to write the name of the variable in all caps to indicate that it's a constant. This is the first time that we're doing some mathematics, or we're calling some mathematical functions. So if you want to call a mathematical function in C, the first place you're going to look for the function is in the header math.h. So that includes many of the functions that you would see in java.lang.math. I don't think you get all of them. Anyway, most of the mathematical functions are declared here. So for example, cosine is declared in math.h. Sine is declared in math.h. Right, so here I'm computing the cosine of some angle. I'm computing the sine of some angle. And then I'm going to print them out. Right. Okay, so not surprisingly, we get out a point 0.86 and 0.5. Right. Pi was declared to be const. So if I try to write to the value pi, the compiler will flag that as an error. Right? Assignment of a read-only variable pi. So that's an error. It doesn't even compile. Void is also a type in C. And so on its own, void means cannot hold any value. And you can use void as the return type for a function, just like you do in Java. Right? So a method in Java that returns no value has a void return type. In C, if a function has no parameters, the parameter list should be marked as being void as well. So that's a I don't remember which version of the language that was brought in. Right. There's also another use of void. So there's something called a void pointer. And so that lets you make a pointer that can point to any object. So when we talk about pointers, we'll come back and revisit what a void pointer is. You can't actually ask for the size of void. That doesn't work. All right, so far everything is pretty similar to Java. Arrays in C, I guess, is where there's a first significant departure compared to Java. And unfortunately, they look pretty similar in both languages. So they have a lot of similarities. Unfortunately, they have significant differences as well. Right. Okay, so in both C and in Java, arrays are contiguous sequence of objects all having the same type. right? Contiguous means in memory they're laid out one after the other, right? The capacity of an array in both Java and C is fixed, right? So you can, once you make the array, you've got that many, in both languages, you have that many elements of the type of your array. So if you make an array of size 5, and it's an array of int, you've got 5 ints, right, in both languages. The way you access and modify elements is with the square brackets, so that's nothing new there. The indexing is between 0 and the length of the array minus 1. No negative indexing. The significant differences are the following. So if you make an array variable, because you want to store an array somewhere, you cannot assign to that array variable. Right? So remember at the beginning of the lecture I said you can always initialize a variable. There are some variables you cannot assign to. Array variables are one of those things that you cannot assign to. Right? You can assign to the elements of the array, right? But once you have an array variable and you've set it to and you've made an array object for it to refer to, you can't make it point at or refer to another array. In Java, when you make an array, you use the new operator. And then you say how big the array, or how many elements you want in the array. So that's not the way you work. That's not the way it works in C. There is no new operator in C. If you know how big your array is, you can simply say how big your array is by putting the number inside of square brackets. So I'll show you that in a second. This is in bold for a reason. So in Java, if you index into an array and the index is not valid, you immediately get an exception. C doesn't care if you use an invalid index. If you use an invalid index, C will try to go into the element at that index and give you whatever's there. Right? If you're writing into an element of the array using an index, right, and your index is not valid, so it's past the end of the array, C will happily write over whatever value you just asked it to. Right? So there's no index bounds checking. You don't get a warning. There's no error. Right? You might get an error if you overwrite something important. But generally, there's no warning or error. And so that's going to cause all sorts of problems in this course, right? And when you program in C. The other funny thing is that it seems like you can't return or pass an array to a function. You can, it's just the way you do it is via a pointer instead. Right, we'll talk more about that later. And so that's the last 2 points here. All right, so how to use an array? So it looks a lot like using one in Java, except there's no new. Right? So if you want to make an array of size 3 and it's an int, you just write that. Right? And you've got an array called x that can hold 3 ints. Right? The elements are never initialized in C. Right? Java always initializes values to 0 or false. Right? C never initializes array values. So here you've got an array of 3 ints. They could have any value. They might be 0. They might not be. Right? So that's how you access an element of the array. Right? If you want to assign to it, no problem. If you want to get its value, no problem. Right? So I'm going to put the values 1, 2, 3 into the array, and then in my loop, I'm just going to print the values at indexes 0, 1, and 2. Right? And so obviously this is going to print out 1, 2, and 3. Right? So nothing really surprising there, except that's how you make an array in C. Right? Okay, so what I'm about to tell you, you should forget as soon as I tell you. All right? So I told you what the size of operator does. It tells you how much memory a type occupies. If you ask for the size of an array that is created like this, right? It will tell you the correct size of, it will tell you the number of bytes of memory needed to hold for that array. Right? And so in other words, what it tells you is how long is the value it gives you back is how long the array is times the size of each element type. Right? So it tells you how much memory the array is occupying in memory. Right? Here I've got an array of 3 ints, so the amount of memory it occupies is 3 times the size of int. Right? So that's the value it returns. So for here, when I print out its size right there, I should get 3 times however big an int is on my computer. I think it's 4, so you should get 12. If you want to know how long the array is, you have to divide by size of int. Right? So there, I'm asking for how much memory is the array occupying, and then I'm going to divide by the size of each element. Right, so size of x is 12, makes sense. Right? How many elements in the array? It's 3, also makes sense. Right? So now that you know how to find the size of an array, you should forget about it. Right? You never have to ask for the size of this array. Right? You know how big it is. It's got 3 elements in it, right? You wrote 3, you know how big it is. Right? Okay, so now that you know what it does, so if you're given a little local array, the way we just created it here, right? Size of will return how much memory it's occupying, right? You never need to know that because you know how big the array is. You know the element type of the array, so you can always compute it yourself. The problem occurs when you pass an array to a function, and then you ask the function, inside the function, you say, how big is the array, right? How many elements are in the array? It doesn't work. Arrays don't work like that in Java. So when you pass an array to a function, the function doesn't get the array. It gets a pointer to the first element of the array. Right? And so when you ask for the size of the array inside the function, you get the size of the pointer, which is always 8 on my computer. Right? So you never get the right answer. It never does what you want it to do. Right? And so forget that you can even write this. Right? It's almost always the wrong thing to do. There's something missing from this list here. Yes. In Java, an array knows how long it is, how big it is, right? Every array has a field called length, right? It knows how big the array is. In C, the array does not know how big it is. You can't ask the array how many elements are in the array. It doesn't know, right? That information is not kept. And so that causes all sorts of problems when you're programming in C. Right, and so we'll see how to deal with that when we start to work with arrays later in the course. No index bounds checking. Right? You're really going to miss this coming from Python and Java. Right? If you C will happily let you use an invalid index. Right? So here is an array of 5 elements. So it's an array of int. If you want to initialize the elements, you can use the braces and then put the elements inside the braces. Right? So this makes an array of 5 ints. Their values are all -9. If I print out the first value in the array, obviously it should be -9. Now I've got an array of 3 ints, right? And I'm going to fill it up. So the first 3 elements will be 1, 2, and 3, and then I'm going to write x3 equals 4. 3 is not a valid index for an array of size 3. The compiler is going to let this happen and not complain about it, right? It doesn't even tell you that, hey, that index is not valid. Right? The problem is the compiler doesn't know that index isn't valid, right? It doesn't know how big the array is. It doesn't keep track of how big arrays are. So even if you wanted to, there's no good way to validate that index. Right? So this is going to work. The compiler will compile this code. It will go into whatever element it thinks this is and overwrite that value. Right? So let's see what happens when we do that. Okay, so we print out the first element of ARR1. It's -9, so we get -9. Right? We then fill in the values of x, including an incorrect value. We're going to ask for how big is x, right? And it tells you it's 12, right? Which is the same as before, right? The array occupies 12 units of memory, right? There's 3 elements in the array, right? Notice what happens here now. I'm going to print out the first element of the other array, ARR1. Right? We haven't touched ARR1 yet. Right? We initialized it here, printed out its first value here, didn't do anything else to ARR1. Notice what happens down here. So when I print out the value of ARR1 now, the value is 4. Right? What's happened? When I wrote into the 4th element of x, right, it overwrote the first element of ARR1. Right? It just so happens that in this program, the compiler has laid out the arrays side by side. Right? So x is in memory, so there's x0, x1, x2, and then right beside it happens to be ARR1. So ARR1 0 is right beside ARR2. So when you write into X3, it overwrites ARR1 0. Right? And you get the 4 here. Right? There's no warning, there's no error. Right? The compiler happily compiles this code and runs. Right? So be careful, there is no index bounds checking in C. Right? This is the source of all sorts of security errors in the C programs. Right? If you can get an array and write past the end of the array, you can write into whatever memory happens to be past the end of that array. And so we'll talk more about this when we actually talk about arrays in depth. Okay, what else are you going to miss? You're going to miss strings from Java and Python. So C pretends that there is a string type, but there isn't. Right? There's even a string library, like a header file that operates on strings. Right? But strings in C, they're not their own type. They're just arrays of char. Right? So even though you can write stuff like this, right, that looks like a string literal, right? Under the hood, there's just an array of characters somewhere that happens to have the value CISC220. Now remember, arrays, the language doesn't know how big an array is, right? It doesn't keep track of that information. So how do you know how long a string is? Right? And so the way it works in C is that there's a special character that marks the end of every string. The special character is that, right? So as a literal, it's \0, right? Numerically, it's the number 0, right? So that's called the null character constant. It marks the end of a C string. Right? All of the C standard library functions that operate on strings expect your strings to have this 0 at the end of the string, right? If it doesn't, the functions will just keep on going until it finds a value that happens to be 0 somewhere in memory. So here, I've got my string sys220. So string literals look exactly the same as they look in Java. Right? But there's no string type. Everything's just an array of char. Right? So if I want a string, it's an array of char. So if you make an array and you don't say what its size is right there, right, and you initialize the array, then the array gets created to have the size that you would expect it to have. So here, the size of the array is 4, 5, 6, 7, plus 1, right? So the size of str is 8 here. Right? It has 8 elements in it. There's the extra \0 sitting at the end of this string that you don't normally write yourself and that you can't see, right? So if you print that string, you get sys220, everything's fine. So there's a difference between the length of a string and the capacity of the underlying array. Right? So remember, a string's just an array of char. Right? The end of the string is marked with a 0. Right? You can put the 0 anywhere you want to in the array, right? And that marks the end of the string. So you can have an array that's 100 characters long, but you can have the 0 at the first character of the array. And so as far as C is concerned, that string has length 0. Right? So come back. All right. So there's my array of char, right? That says I have an array of char of length 100. Right? If I initialize that with the string sys220, right, then the first character of str is C, then ISC220, and then there's a 0, the \0, sitting in the 8th character of the array. Right? The other elements of the array, they're there, but they're unused by the string. So how big is that string? Well, it has capacity 100. Right? How long is the string? Well, the string has length 7. Right? The string length function tells you how long a string is in C. Right? All right, so remember what I told you. A string uses the \0 to mark the end of a string. Right? And so how does string length work? It iterates over the elements of the array until it sees a 0. Right? And so that means to find the length of a string in C, it's on in the length of the string, which is another problem with strings in the C language. Right? Doing something as simple as looking for the end of the length of a string is not a constant time operation. Right? The string length function has to search for the first character that's equal to 0. And so that's very different than the way Python and Java work. Right? They both have classes, or they both have objects to represent strings, where each object knows how long the underlying string is. Right? If you ask a string in Java or Python how long is it, it can do that that's a constant time operation. Oh yeah, the string length does not include the null terminator character. Right? So when you ask how long is that string, it's 7, right? It's not 8. Right? You need an array of size 8 to hold the string, but the length of the string is 7. All right. So here we're using a function called malloc. Malloc is the way that you allocate is one of the ways that you allocate memory in C. So the way I'm using it here is I'm asking for enough memory to hold one character. Right? Malloc returns what's called a pointer. So if you don't know what a pointer is, don't worry about it. That's a pointer to car here. You can pretend this is just an array. Right? So I can write str0 equals the C, right? And notice what's missing here, right? I've got an array of length 1. I put a C in it, right? There's no null terminator, right? So I haven't put the null terminator in, and so when you ask string length, how long is this string? This says 5, right? Right? You want the answer to be 1 in this case, right? But because you didn't put the null terminator into the string, string length doesn't give you back the correct answer. Right? If you run this again, you may not even get 5. Oh, I guess you're getting 5 again. Right? If you run this on your own computer, you might get a different answer. So it's not necessarily 5. Right? Wherever the first 0 happens to be after the start of this string is what string length will give you back as the length of the string. All right, what time do we have here? We have 2:17. Okay, so I guess this is a good place to stop. So we'll finish off this notebook on Thursday, and then I guess it's reading week. All right, any questions about the lecture today? Okay, so see you in a couple of days.